Hello. I'm going to solve a few questions from May 2024 P2 paper, and it is a special R paper. So there are two papers for 2024. One is simple and one is R regional. So I have selected few questions and mostly I'll be talking about arithmetic and geometric sequence and series. So if we start with the first question of the paper, it's here. So we are given a recurrence formula, un plus 2 equals 3un plus 1 minus 2un. Given that u1 is 7, u3 is 4, find the value of u2. Okay, so that is our first part, find the value of u2. We know that in this case, we are given u1 and u3. So u3 can be written as, if we take n1 in this expression, so we get 3 here. So when n is 1, we replace n equals 1 everywhere here. So we get u1 plus 2, which is 3. u1 plus 1 is 2 minus 2u1. So we know that u3 is 4. u2 we have to find. u1 is 7. So rearranging this, we'll get 4 plus 14 equals 3u2. This is 14. So 7 times 2 is 14. Taking to the other side becomes plus 14. So 4 plus 14 is 18. So 18 equals 3u2. So u2 will be 18 divided by 3, which is 6. So we got the answer for this part B. Coming to part B now. Now this is a common area where students usually don't understand what to do. So this symbol means sum. Now what to sum? And for that we are given this information along it, so that we have to take the values of the given expression by replacing r by 1, 2, 3, up to 4. So at the bottom, we are given the starting point, starting value, and at the top, we are given the last value we have to go up to. So that means if I take r equals 1 first, so what do we get? We get u1 plus 2 times 1. This is my first expression, first value when I take r1. And then this sum means I have to add by taking the next value of r. So whatever the next value of r, that will come after this plus sign. So if r is 2, I'll write here u2 plus 2 times r is 2. Then we have to take r3, but we have to add next term. So when r is 3, we get u3 plus 2 times 3. In place of r, we are writing 3 everywhere. Lastly, r is 4, because that is the number tells us that we have to go up to 4. Last value of r will be 4. So u4 plus 2 times 4. So this is what is this equals to. Now we can see that we have u1, u2, u3, u4. Then this is 2. 2 times 2 is 4. Now I'm going to write these expressions. This, and this. First I have written u1, u2, u3, and u4. I collected them together. And now I'm going to add these numbers parts, so which is 2 plus 4 plus 6 plus 8. Now the sum of u1 to u4, we don't have u4, we already have u1, we have calculated u2, we have u3, but u4 we don't have, so we need to calculate u4 in order to place that here. To find u4, we have to use this recurring formula. So we know that un plus 2 is equals to 3un plus 1 minus 2un. So if I want to get 4 here, so I need to take n equals 2 to make it 4. So if n is 2, I will get 2 plus 2, 4. u4 will be equals to 3 times u. Remember, we are taking n equals 2. So 2 plus 1, 3. Minus 2, again, n means u2 and u2. So u4 will be 3 times u3. What is u3? u3 is 4. Minus 2 times what is u2? We just found here in the first part, which is 6. So we get here 12 minus 12, 0. So u4 is 0. So then we need just put two values of u1, u2, u3, u4. So u1 was 7. u2 is 6. u3 is 4. And we just calculated u4, which is 0. And then we need to add all of these together. So 6 plus 4, 10 plus 10, this is 20. And now we'll add all of them together. So this is 10, 30, so 37 is the sum. So this notation, you need to understand that this means to add, and not only add, but what to add. That's important to understand, that whatever the number mentioned here and the variable mentioned here, we will change its value starting from the value given here up to the value given under this number. So changing from this and the next number and next number up till you reach to the top number. Let's say you have sigma, this is called sigma notation. So sigma n equals 1 to 10. It means you have to take the values for n as 1, 2, 3, 4, so on up to 10. And then in front of that, whatever is given, you have to replace this values of n in that. Let's say you are given 2n. So it means every time you have to replace n by the values which are from 1 to 10. And we will add them because it's sum. So that is how we answered question number 1. Then we have another important question on sequences itself. And sometimes this is now 24 exam. So this was a question, first part. In an arithmetic series, the first term is a and the common difference is d. Show that sum to n term is this. So most of you are familiar with this, that this is the sum formula. But from where it comes, we need to show, we have to prove that this is the sum formula for the arithmetic series. So how to prove it? Now this is the question, and this carries 3 marks. So there is a process, there are steps you need to follow in order to prove this. So as we are told that the first term of the sequence is A and the common difference is D. So we can generate the sequence. And how we can do that? So our first term is A. If the common difference is D, then the second term should be A plus D. Third term should be A plus 2D. Every time we add one more D. And A plus 3D. It goes on. And because we have to write up to n terms, so the last term that could be written as A plus some number of D's. So how many D's do we have written? So we have to just check carefully. This is our first term. This is second term. This is third term. This is fourth term. Just check the connection between the term and the number of D's. So the number of D's are one less than the position, that is term number. So term number 3 means 2D. Term number 4 means 3D. Term number 5 means 4D. So term number n will be 1 less than n number of D's. So n minus 1D If we have to write the previous term of this, it will be n minus 2d. So this is our sequence. Now, because we have to show the sum, so it means the sum of the sequence Sn will be equals to a plus c, a plus 2d, and so on. It goes like that. And all the way we have to go up to the n terms. So we have to write actually two terms. Instead of writing last term only, we write second last and the last term. So let's write the second last term. Second last term will be a plus, second last term will be n minus 1 term, and the last term will be n term. So how many d's we have to write here? Whatever the position, one less than that. So n minus 1 minus 1, that becomes n minus 2. So we have n minus 2 d's in the second last term, the n minus 1 term, plus, and nth term will be a plus n minus 1d. So this is our sum of all the arithmetic, the terms of an arithmetic series. Now, in order to find the formula for the sum, what we need to do is we need to rewrite this sum again, but this time we have to write in opposite order. The last term we will write at first. The last term was nth term. We place it here. We are simply writing in reverse order the first sequence, the series that we have mentioned above. We just write in the opposite order. So last term, then second last term. And it goes on, and we have to write the first few terms which are in the first sequence at the end. So let's write the last term, second last term, a plus d, and the last term will be a. So in this sequence, first sequence, whatever the terms are there, we just put them in the second line, another line, in just reverse order. Last term becomes first, second last term becomes second, first term becomes last, second term becomes second last, and this on. Now, so both of the lines have same numbers. So if you add them, you get the same results, Sn, Sn. Now we are going to add these two equations. So if we add Sn plus Sn, we get 2Sn. And same way we will add the terms because we have same number of terms in both the lines. So we can pair them up, like this will be our first pair. First term and the last term. Second term and the second last term. Third term and the third last term. So if we add this first and last term, what we get? A plus n minus d. So a plus a is 2a and n minus 1d. So this is the sum of first two terms, first pair, plus if we add the second pair, so a is here, so a plus a becomes 2a. Here we have 1d, and here we have n minus 2d. So because these are like terms, so we can add the number of d's. So n minus 2 plus 1 is n minus 1. So we have n minus 1d. So because we can add a to a only because they're like terms, so that's why a plus a is 2a. And d are like terms. So how many d's are in the first expression? 1d. In the second expression, we have n minus 2d's. So if we add them, so n minus 2 plus 1, we get n minus 1. So there are n minus 1d's altogether in the second sum of the second pairs. And we carry on like that. So second last term and the second term will be added together, and last term and the second last term. The last term and the first term actually to be added together. So when we add the second last term, we get again a plus a 2a, n minus 2d plus 1d, n minus 1d again. So that is the sum of this pair plus the last pair is a plus a 2a plus n minus 1d. So as we know that we have n terms in each sequence, we have written the terms from 1 to n. So we have n terms. So it means we have n pairs, 1, 2, 3, so on, n minus 1 and n. So we have n terms. So we have added n pairs. And now what we are getting? We are getting 2a plus n minus 1d, 2a plus n minus 1d. In every pair, when we added them, we are getting the same thing. It means we are adding this same thing how many times? N times, because we have n terms, n pairs. If we add them n times, the sum will be n times of this. It seems like if you need to add, let me give you an example here. If we are adding 7, 7, 7, let's say we have 12 sevens. We go up to 12 numbers we have here, 12, 7, all are 7. So what will be the sum? So we don't need to add individually. We know that it means 7 times 12, 12 times 7. 7 appears 12 times. So it means the sum will be 12 times 7, 84. So same way, this n minus 2a plus n minus 1d appears n times because we have n terms. So the sum will be n times this. So now we have got 2Sn equals this thing. Because we need only Sn, so we'll divide this 2 on the other side. So we'll get Sn equals n over 2a plus n minus 1 d, and which is the formula for the sum. So this is the sum formula for the arithmetic series. And before answering the remaining question, I will also explain you how to prove geometric sequence formula, because if in 2024 this question was there for arithmetic, so there may be a question in the next exam about geometrics, prove the sum of geometric series, the formula for the geometric series. So the process is almost similar, but a little bit difference is there in the technique. So we know that in a geometric series, first term is A. And instead of common distance, common difference, we have common ratio. Because we multiply or divide the terms to get the next terms in geometric series. So R is the common ratio. So what are the terms of the sequence then? First term is A. Second term will be A times R, AR squared, and so on it goes. And we want to find the sum of n terms. So we have to go up n terms. So second last term will be, now again the same observation to be made here. We have first term, we have second term, we have third term. So what is changing in each term? Only the power of R is changing. In the first term, we have no R, that means R power 0. In the second term, we have R power 1. In third term, we have R power 2. So what is the connection between the power and the position? So power is 1 less than the position. So if I want to write 20th term in the sequence, so it will be AR 19, because power will be 1 less than the position. So similarly, if I want to write the nth term, so an nth term will be AR n minus 1, 1 less than this. And the previous term will be AR, because previous position will be n minus 1. So I have to subtract 1 from it. So n minus 1 minus 1, that becomes n minus 2. So AR n minus 2. So these are the nth term of this geometric sequence. Now, because we have to find the sum, so we can say that sum to n of this series will be A plus AR plus AR squared. And it goes like that. Second last term will be AR n minus 2. Last term will be AR n minus 1. Now, what we do here, we multiply all the terms by R. On both sides, we multiply by R. If we multiply the left side, we get R times Sn. On the right side, every term will be multiplied by R. We get AR squared AR cubed, and so on. AR n minus 1. When you add 1 into this, n minus 2 plus 1 will become n minus 1. And lastly, AR power n minus 1 plus 1 will become just n. Now we will subtract these two sums, Sn and Rsn. We will subtract. So the top equation minus bottom equation. So that means Sn minus Rsn. It means we have to change the sign for the second line. So this will become minus. Whether you show it or not doesn't matter. All this will become minus. So now if you just observe carefully, what do you notice here? That second term and the first term is same here. Third term and second term are same here. It means the next term will be same here. It goes like that. The second last term will be same with the previous term. The last term and the first will be same as this. So in that way, we are getting pairs of terms which are exactly same. Only the first term and the last term in the first sequence and the second sequence don't make pair with anything. So only A in the numerator in the first sequence series and the ARN in the second series is left out. All others are similar. So when we subtract them, they will cancel each other. A minus AR, it will cancel each other. AR squared minus AR squared canceling each other. So whatever is left out, we have to write that. So A will be left out from the first one minus ARN is left from here. So only this and this is left. So A minus ARN is left. So now we can take Sn common from the left side. We get 1 minus R. We can take A common from the right side, 1 minus Rn. And now we can just write Sn. We divide by 1 minus R on both sides. So we get this. So this is what is the sum to n terms of a geometric series. This is the proof of this formula. Because this formula can be written in two ways, 1 minus R or R minus 1. So in that case, you can subtract bottom minus top. This you can write on the top and that minus bottom. So in that case, you'll get R Sn minus Sn. So in that case, when you take Sn common, you get R minus 1. Same thing will be on the other side. So you get the other form of this formula. But anyway, directly also you can write this, because if you just change the signs of top and bottom, you get the other form of the formula, A Rn minus 1 over Rn minus 1. So it doesn't matter which formula you use, which form of the formula is used, any one you use, the result will be same. Doesn't matter. In any scenario, you can use this, any of the formulas. So this was the proof of arithmetic and geometric series, the formulas, and I suggest you to practice them very well. It is expected that this may appear in the next exam because we have seen arithmetic sequence formula in the previous exam. So most probably this geometric may come there. So prepare both of them because anyone can come here. So we have answered first part of this, although I have added extra geometric sum. Now we come to the second part of this, B. So hence find, as you are given the expressions 900, 892, and so on. So this is the sum of the series, and we have to check whether what type of series it is. Hence means we expect that it should be an arithmetic series because in the previous part, we have dealt with arithmetic series. So let's check it. So the common difference will be 900 minus 822 minus 900 is 8, negative 8 because it is decreasing. Again, if you subtract 8, you get 84. So we are subtracting 8 every time to get the next term. So it means the first term is 900. Common difference is negative 8. And we also need n. How many terms we need to add? So we don't know what is the position of 500. So if you refer to the formula sheet, you know that this formula is also same as n over 2 first term plus last term. Although we have first term and the last term, but we don't have n. Anyway, we have to find n. So n means what position is for 500. So we have to use the nth term formula for that. So we know that un is a plus n minus 1 d. So we know the value of un. We know the first term. We want to find n. And we have the value of d. So taking 900 to the other side, 500 minus 900 is minus 400. 8n, which is negative 8n, plus 8. Rearranging this formula, we get 8n equals 408. So n will be equals to 408 divided by 8. Which gives us 51. So it means this term is 51st term. It means we need to add 51 terms. So now we can use the sum formula. So sum to n term means sum to 51 term will be n over 2, 2a plus n minus 1. So 51 is n. So n minus 1 means 50 times d. Or if you want, you can use this formula, a plus l, directly, just adding first and the last term, and we can get the answer. So that is more quicker, but anyhow, we have written this now. We can continue with this. So we'll calculate this. 900 times 2 plus 50 times negative 8 is 1,400. Which will give us 35,700. So that is the answer of part B. Sum of this series is this. So this is part B. Part A I answered there. Then next is, given that the first three terms of a geometric series are this: k plus 4, k minus 2. K plus 4, k minus 2, and 11 minus k. So these are the three terms, and these are first three terms, where k is a constant. Show that this equation holds. So this type of questions, we know that because the geometric sequence, and there are first three terms given, so the common ratio between any two consecutive terms must be same. So first two terms, the common ratio will be second term divided by first term. And similarly, third term divided by second term should also give us the same common ratio. So it means 11 minus k divided by k minus 2 must be same as the first ratio. So we will write it like this, and then we cross multiply and we bring that equation which is required. So k minus 2 squared is k plus 4 times 11 minus k. If we expand this is k squared minus 4k plus 4. And this will be expanded, so 11k minus k squared plus 44 minus 4k. So this will give us 11k minus 4k is 7k plus 44 minus k squared. So as we know that we have to bring the equation in which everything is on one side and the right side is 0. So let's move the terms from the right to the left. So k squared minus k squared will become plus k squared. So k squared plus k squared, 2k squared. So minus 4k plus 7k will become minus 7k. So minus 11k. Plus 4 plus 44 will become minus 44. So minus 44 plus 4 is minus 40 equal to 0. Is it the same thing that we are asked to prove? 2k squared minus 11k minus 40. Yes. So we have shown that this holds. So this is a very common thing. Sometimes you are given for arithmetic series, 3 consecutive terms. Sometimes it is told about geometric. So if it is geometric, the common ratio between the first two terms should be equated with common ratio of the last two terms. Same goes with arithmetic series. If it was arithmetic series, the difference between the first two terms must be equal to difference between third and second term. Like suppose this was given that is an arithmetic. So you will say k minus 2 minus k plus 4. That will give us the value of d. Must be equals to, I have used the first two terms to find the d. Now I use the second and third term. So right term minus left term. And that will form the equation and we can solve it, or whatever we are asked to do, we can do. That main thing is how to form the equation. So that is how we form the equation for this case, if it is arithmetic instead of geometric. Okay, so the next part is show that this is, and given also that this series is convergent. Find the value of S in sum to infinity. So convergent means we can find the sum to infinity, and that is possible only when the value of R will be less than 1. Absolute value of R will be less than 1. That means actual value of R will be between minus 1 and 1. If it is convergent series, geometric series, then the value of R will be between minus 1 and 1. Now, how to get the value of R? So as we, in the previous part, we found equation. Now we'll solve this equation to find the value of k. And once we have the value of k, we can find the common ratio after substituting the value of k. So let's solve this equation now to find the value of k. So you can solve it by any method that you like, quadratic formula, completing square, or factorization if possible. So let's try to factorize it, or let's do formula method. So k equals minus b squared minus 4ac over 2. As I repeatedly told that, always mention the formula. Don't directly calculate and from your calculator, don't write the answer only, but at least write the formula, substitute the values, and then work out what are your answers directly. You can write that. So now we are going to calculate what is this. So I'm just calculating it, 441. So this is 21, so 11 plus minus 21 over 4. So that means the values of k, because it's a quadratic, so we are expecting two solutions of that, so two possible values of k. So this gives us either value of k will be by taking plus 21 plus 11 divided by 2 divided by 4, which is 8, or 11 minus 21 divided by 4, which gives us 11 minus 21 by 4 is negative 2.5. Okay, I think I made some mistake in this calculation because we can't get these values. So let me check that again. 121 times 11 plus minus 21 over 4. All right, so we got the values of k, everything is fine. So it's 8 and negative 2.5. So now we can use these values to find the value of r. So now what is our, what do you call it? The series k plus 4, k minus 2. Let's write only first two terms. K plus 4, k minus 2. So what will be the r? K plus k minus 2 over k plus 4. So if we take 8 as k, so 8 minus 2, let me write here, if k is 8, r will be 8 minus 2, 8 plus 4, which is 6 over 12 or 1 over 2. And if k is negative 2.5, then r will be negative 2.5, negative 2 over negative 2.5 plus 4, which will give me negative 4.5 over 1.5, which is 3, negative 3. So as we are told that the geometric sequence is convergent, as the GP is convergent, so R cannot be negative 3. So therefore, R is 1 over 2 or 0.5. As I told you in the beginning itself, that if it is a convergent series, then a value of R will be between minus 1 and 1, or absolute value. Without sign, the value should be less than 1. So if we are checking both of these answers for R, so this is not, when we take the absolute value of R here, absolute mean without sign, it is 3, which is not less than 1. So therefore, it is not a convergence series if we take this value of R. However, R equals 0.5 is fulfilling that condition. So now we can use this value of R to find the sum to infinity. So sum to infinity is A over 1 minus R, which means A is k plus 4. Let me write here. K plus 4, 4 minus R is, and we know that the value of k, which gives us this value, we have to take not this value, because that leads us to a value of R that is not required in this case. So k is 8, so we have to take 8 plus 4 over 1 minus 0.5, which is 0.5. So it is 12 times 1 over 2 is 24. So sum to infinity is 24 for this question. Okay, so we have answered all the parts of this question. Now, just one trigonometric question, which is not actually exist in the textbook, and we haven't discussed this set of questions. Although we should be able to do it because it's not that difficult, but let's discuss this quickly. The depth of water d meters in a harbor on a particular day is given by the equation here. D equals 8 plus that. And the t has values possible between 0 to 24. where T is the number of hours after midnight. So D represents the depth of water, and that is in meters. And T is the time passed after midnight. How many hours? This is in hours, and the time after midnight, that is night 12 o'clock. How much time has passed? That is represented by T in hours. Show that the depth of the water in the harbor at 2 a.m. is just over 4 meters. Just over 4 meters means little bit more than 4. So depth of the water we have to find, or we have to find actually, and that answer should be nearly 4 meters, little higher than 4 meters. When the time is 2 a.m., which means how many hours have passed after midnight? When it is 2 a.m., 2 hours. So it means T is 2. So in this formula, we substitute T2 and we will get the value of D. D is the depth we have to find. So 8 plus 5 sine 2 pi, because T is 2. So 2 pi over 6 plus 3. And you can just plug in this whole thing into calculator and you can get the value. And let's see what do we get. So it is sine pi by 3 times 5 plus 8. So I am getting it 4.0660 meters. So therefore, depth at 2 a.m. is just over 4 meters, because it's just, and this number is little bit more than 4. So just over 4. Okay, the second part of the question, find to the nearest minute the first time after midday. After midday, midday means noon, 12 o'clock in the daytime. So how many hours will be passed after midnight when you reach to midday? So from night 12 o'clock to day 12 o'clock, there are 12 hours passed. So we have to find that time which is more than 12, because 12 hours passed till midday. So after that, at what time the depth of the water will be exactly 6 meters. So D we know now, it is 6 meters. So the value of D is 6. We have to find the value of T, and that T should be greater than noon time, which is 12. From midnight till midday, there are 12 hours. So value of T will be more than 12, because it says after midday. So after 12. So T should be greater than 12. And that we have to find the value of T by solving this equation. So what is the equation now? We replace D in place of 6, 6 in place of D. So it will be 8 plus 5 sine equals, we know that it is equal to D, which is 6. Now rearrange it. So we get 5 sine is equals to 6 minus 8, which is 2. We brought 8 to the other side. And finally, we get sine 5t over 6 plus 3 equals negative 2 over 5, which is negative 0.4. Or you can write like this also. Now we have to solve this equation, and we learned that when we want to solve this for t, so we should know the range for t. We are told that t can be only between 0 to 24. So we know that the value of t should be between 0 to 24. It cannot be 24. It should be less than 24. Now, we are solving this equation, so we need to transform this t into pi t over 6 plus 3. So it means we have to multiply this by pi first. Then we'll divide by 6. Then we add 3. So multiply by pi, 0 multiplied by pi is 0. Divide by 6 is 0. Add 3, we get 3 here. And 24 multiplied by pi divided by 6. 24 divided by 6 is 4, so it will be 4 pi, and then we add 3 also. So this is our range that we have to consider while solving this equation. So let's call this expression pi t over 6 plus 3 equals p. It means the values of p are in this range. So, and our equation becomes simple. Sine phi equals negative 2 over 5. So now let's see how to solve this. So we'll find the first value by calculator. Sine inverse of negative 2 over 5, which is, and remember that we are talking in terms of pi, so it should be in radians. It's not in degrees, so your calculator should be in the radian mode while calculating this. So sine inverse negative 2 over 5, which gives us negative 0.4115. And then, as we know that we need to find two values for the sine. So this is P1, we can call it. P2 will be pi minus our first answer. Pi this gives us 3.5531. And after that, we can find multiple further values of p by adding the period. So the values of p will be, the first value is negative 0.4115 and 3.5531. We also have to refer to the range. So the first value is definitely not in the range, so we will not consider it in our final answer, but the second value is in the range. However, we can use the first answer to find more values by adding 2 pi into it. So let's add 2 pi into the first answer, negative 0.4115 plus 2 pi. So we get 5.8717. If we know that this is 4 pi, the upper limit is 4 pi plus 3. So what is 4 pi plus 3 in decimals? Is 15.566. So it means we can go up to this value in decimal, 15, and still we just found 5. So if we add again 2 pi into this, plus 2 pi again, so we get 12.154. Then it's the same process we'll do for the second answer, 3.5531. We'll add 2 pi into this, 5531 plus 2 pi. It gives us 9.8363. And again, adding 2 pi into this, it gives us 16 point something. Let me write it here. So we clearly know that this value is not in the range, that goes out of this range. This value is not in the range, so remaining 4 values are there. And these are the values of p. Now we will convert this back into t. So what will be the values of t that we will get from each of these? So how we get the value of t? We know that p is pi t over 6 plus 3. So in order to get the value of t, first we have to take away 3. Then we will multiply by 6. And then we'll divide by pi. So that will give us the value of t. So taking 3 first to the left side, that is the first value to be done, p minus 3. Then multiplying the denominator, so 6. So this order to be followed. So each value of x to be, each value of p to be converted into t by this method. So first value is 3.5531. First we'll take away 3. Then we will multiply by 6, then divide by 5. So we get 1.056. This was we are done with. Then I'm taking the second value, which is 5.8717 minus 3 times by 6 divided by 5. So it gives me 5.4845. This is also done. Then 9.8363 minus 3 times 6 divided by 5 gives me 13.056. And lastly, although I have got my answer, but just let's find the last value also. So subtract 3 times by 6 divided by 5, we get 17.483 or 29. Okay, now interpret the results. So we know that these are the values of t, and what is t? T is the time after midnight. So we are looking for the value of t which is greater than 12 after midday. So which time is after midday? Here and here. So this is the time immediately after 12, the first time it appears. So it means the water level will be at 6 meters at these times, all these times. But we have to look for that time, which is immediately after midnight. So which is this one. So what we are asked to write, or we asked that time of the day, find to the nearest minute, first time after midday. So we have to write in minutes and nearest minutes and time of the day. So it means from midnight to midday, it is 12. And then how much more is there? 13 means 1 hour have passed after midday. So 13 in 24-hour clock, it will be 13 hours and this many hours, 13.056 hours is the total time. So we can split that. It is 13 hours plus 0.56 hours. And we can change this into minutes by multiplying it by 60. So anytime in hours, we can change into minute by multiplying it by 60. 0.56 times 60. I think I missed 0.05. It is gives us 3.36, 13 hours. So that means the time of the day was 13:03. So that is the result. That is the answer that we need to mention. So to the nearest minute. So these are 3.3 minutes. So 3.3 minutes means 3 minutes to the nearest minutes. So after midday, it is just 1 hour pass, which is 13. And then 3 minutes have passed. So 13.03 is our answer. At this time, the depth of the water would be 6 meters there. So that is how we can solve. So I have given you the example of trigonometric application and geometric and arithmetic proofs for nth term formulas. And we solved some more questions. So that's all for this session. Thank you.